Good evening to all. In the previous video, we have discussed some classification of systems, how we can find the system, whether it is static or dynamic or causal or non-causal or linear or non-linear, and about the time invariance property also we have seen. In this video, we will solve some gate problems based on that classification of systems. So this is problem number 1, which is asked in GATE 2021 and it's given for 2 marks. The question is, if the input x of t and the output y of t of a system are related as y of t, that is equal to maximum of 0, x of t. The system is whether it is linear and time variant or linear and time invariant, non-linear and time variant, non-linear and time invariant. So they asked for two classification. One is about linearity, other is about the time invariance. Okay, so we have to check the two things. So let me solve the problem. So what they given? Y of t equal to maximum of 0, x of t. Okay, first we will check for linearity. So what is the condition for linear system? The system has to satisfy the superposition principle. So in the previous video we discussed the superposition principle. That superposition principle is nothing but response of weighted sum of input signals that should be equal to weighted sum of output signals. Okay, transform of ax1 of t plus bx1 x2 of t, that is equal to a y1 of t plus b y2 of t. So this is weighted sum of output signals and this is response of weighted sum of input signals. Okay, so this is the principle. The system has to satisfy this principle. First let us find for x1 of t. If x1 of t as the input, then output will be equal to, we are replacing x of t as x1 of t. So maximum of 0, x1 of t. And for x2 of t, the output will be equal to y2 of t equal to maximum of 0, x1 of t. Now first we will find the response of the weighted sum of input signals. Response of the weighted sum of input signals. x2 of t, response of weighted sum of input signals. That means replacing the input by this whole thing. Okay, so maximum of 0, in the place of x of t, we are replacing this whole weighted sum of input signals. So this will become ax1 of t plus bx2 of t. Okay, so this is taken as first equation. Let me find the other in the other direction, that is weighted sum of output signals, that is a y1 of t plus b y2 of t. See, already we found y1 of t and y2 of t. Let me substitute in this. Okay, so a y1 of t plus b y2 of t, that is equal to a into maximum of 0, x1 of t, okay, plus b into maximum of 0, x2 of t. This is x2 of t. Okay, so this is response of weighted sum of output signals. This is response of the weighted sum of input signals. So let me take this as second equation. So see the first equation and second equation, it is not equal. So superposition principle is not satisfied here. So the system is non-linear. Okay, so we can tell this system is non-linear. This is a non-linear system. Okay, so now let me check for time invariance. We'll check for time invariance property. So whether the system is time invariant system or time variant system. So let me check for time invariance. Time invariance. So what is the condition for time invariance? So this is a continuous time signal. So y of t comma t, that should be equal to y of t minus t. So what does mean by that? This is output due to delayed input. That is, input should be delayed, output due to delayed input. So that is nothing but transform of x of t minus t. Okay, so this is the delayed output. Delayed output. So let me solve the problem. What is the equation? So what is the equation given? Y of t equal to maximum of 0 comma x of t. So let me find y of t comma t. That means output due to delayed input. So that input should be delayed by t seconds. Okay, so this will become maximum of 0 comma x of t minus t. Okay, and then y of t minus t, that is delayed output. The output should be delayed. Okay, output should be delayed means in the place of t, we have to replace t minus t. So here maximum 0 comma x of, here only t is there. So x of t minus t. So let me take this as first equation and this is second equation. So both equation are in equal value. So 1 equal to 2. So time variance principle is satisfied. So this is this system is time invariant system. Time invariant system. Okay, time invariant system, and it is a non-linear system. So option D is correct one. Option D is correct one. Okay.